Okay, so at this point, we're going to go ahead and create a knowledge base that we can use on this sheet layout here. And we're just going to go in and we're going to, let's just create another, sorry about that. Let's go ahead and create a new file for our knowledge base. And we're going to use this new file as a template for creating our knowledge bases. It doesn't have to be this knowledge base. It can be any knowledge base. You can do all of your operations in one file that you want in your different knowledge bases. And at this point that we're working here, the knowledge base at this point is not associated with this sheet. Okay, so you don't even need to look at this sheet to create the knowledge base. So we're going to go new, and we're going to go inches. Okay, so we've got a new, completely new part displayed, and we got a number of layers up here. Let's go ahead and delete these real quick so you don't get confused here. Okay. Now, for the knowledge base, we're going to create the knowledge base based on layers, which means that everything in a certain layer is going to be machined with a certain operation. So if you recall the shape of our panels, we had basically an outer perimeter of all the parts, and we had some parts that had cutouts in the middle. So we've got an outer perimeter and an inner perimeter. So we're just going to create two layers here. We're going to call it outer to be simple, and then we're going to create another one and call it inner. Okay, so these are the two layers that's going to be used to assign, to grab the geometry from when the knowledge base is applied. Okay, so now we're just going to go up in here and we're just going to create two operations for our knowledge base. If you recall, with the flat panels, as I mentioned, we have an inner and an outer. We're going to use a profiling operation to do the outer perimeters, okay? And then we're going to use a two-axis hole profiling operation to cut the circular holes for our components. So we're just going to create some just dummy shapes here. We're going to make one square, and we'll make one circle, okay? And as I mentioned, this geometry does not have to be associated with your sheet. It doesn't really matter at this point. We're just using this geometry to serve, to create the operations that's going to be in the knowledge base. So we're going to go up to two axes, and we're going to do profiling. And we're going to select our rectangle. And we're going to, at this point, we're going to completely program this profiling operation. We need to create a tool. So we're going to create a flat end mill, a 1/2 inch diameter. All the default parameters are fine. So we're going to save this as a new tool, and we're going to exit. Okay, so now here's our flat end mill, a 1/2 inch. Feeds and speeds, we're going to skip over. We're not going to talk about those. Clearance, we're going to give it. Now, since at this point, our knowledge base doesn't know what the thickness of the sheet is yet, so we're just going to give it a thickness that's, a clearance plane that's high enough off of the XY plane to encompass our sheet. So we're just going to say 1 inch for the clearance plane definition, and we're going to leave the cut transfer method to the clearance plane. For the cut parameters on this operation, tolerance is going to be 1/1000th. We're going to use a mixed cut direction. We'll start point, we'll use it at the midpoint of the longest side of the component. And for the cutting side, we're going to use inside, outside for closed curves. So if you recall in our panels, we had on three of the panels, we had interior cutouts. So this operation we applied to the outside and then also the inside. So we're going to use inside outside for closed curves. We're going to cut the outside, and then we're going to pick this alternate using nesting, which means it's going to also do the inner cutouts and automatically figure out the inside versus outside. So it's going to do all that for you. So we got the parameters for cut levels. At this point, we don't know what the thickness of our sheets are possibly. So you may apply this knowledge base to flat panels that are, ours is 0.709, but if you have one at 0.5 or 0.625, okay, you can use the same knowledge base to cut all of those sheets. And to do that, we're just going to set the geometry at the bottom. So our geometry is going to be on the XY plane, and it's going to be on the bottom of our sheeted components, okay? So that allows you to apply this to a number of different possibility operations. So we're going to do at bottom, the total cut depth in our part, as we're just going to put 0.709. This can be the exact thickness, or it can be a thickness is a little bit higher. It could be 7.5. Okay, and if you want to do this to multiple sheets that are a little bit higher than 709, you can make this 0.75 or even 1 inch, whatever you want to do. That's the height that it's going to actually cut. So we're going to set it to 0.709, and we're going to hit the tab key, and it's going to apply the 709 to the rough depth, 709 to the rough depth per cut. So we're going to have one cut at the bottom, okay, and it's going to be one cut level at the bottom. If you want to have multiple levels, you can do everything that you need that you want to see on your sheets. Whenever you apply the knowledge base, you can set them here. And we're going to do the depth first for each cutout or perimeter. Entry exit, we're going to use a long path, and we're going to use lines. Let's use none for the exit, because with these panels are going to be relatively close together, so we don't want to use lines and arcs. We don't want to extend our entry exit out past the perimeter. So we're using a long path. We're going to use none, and then we're going to set an overlap here 1 inch to clean up the start point. Okay, so advanced cut parameters. We don't have any arcs on this particular panel, but you may apply this knowledge base and you may have arcs on other parts. So we're going to set the arc fitting tolerance to 2 times the global tolerance here. And everything else, if you needed to add bridges and tabs, we're not going to do that. Corner parameters. I like really sharp corners, so we can set it to go past the corner without having to roll around the corner and degrade that sharp corner. So we're going to use sharp corners, and we're going to use sharp corners on any inner cutouts. Sorting, it'll automatically sort your profiles. We're going to do it based on minimum distance. Let's generate that. Let's turn that on. So there's our first profiling operation. And we're going to create another one, which is the hole profiling. So let's go up here and move along. Let's move along a little bit faster. So we're going to go hole profiling, and we're going to use this circle, okay, for the geometry. And we're going to use the same tool. Feeds and speeds, clearance, all is going to be the same. For the parameters, a tolerance of 1/1000th. The location of cut geometry is going to be at the bottom. Now, this is important because this determines where the knowledge base is going to go and where your curve. We're going to set it up by selecting everything on a certain layer, and those curves on that layer are going to be on the XY plane. So you need to make sure this is set to the bottom, at bottom. And for the hole depth, we'll make that the 709, which we know is the thickness of our sheet. And everything else is fine. Entry and exit. We're going to do a long path to keep it tight in this circular perimeter, and we're going to pick none, and we'll also do an overlap here. Okay, sorting again, minimum distance. Let's generate that. Okay, so we got 2 operations. We got a profiling, which has 1 cut level. We have a hole profiling, and hole profiling, it's based on the pitch of the helical motion. So our pitch is probably, smaller, obviously, than the thickness of the part. So it made a couple of rounds of this helical path to get from the top of the sheet down to the bottom. Okay, and here is our our ramp entry. Okay, at this point, these are the two operations we're going to use in our knowledge base. These are the two operations we're going to use to cut the sheet. So at this point, we can go ahead and create the knowledge base. So we're just going to select the setup. We're going to go to the knowledge bases menu. We're going to say save the knowledge base. And it's asking you where you want to put it. So I'm just going to put it here on my local machine. Okay. I'm going to put it in here. I have one already in there. I'll just override it and just give it a name that you understand so you can identify what operations or what application that knowledge base is for. Okay, so we're just going to use KB template complete. We're going to overwrite that one and pick yes. So at this point, we use this template file. Let's go ahead and save this file as a template, or just save it. I guess we could save it as a template, but we'll just save it here and we'll just name it KB template. Okay, file. Okay, so we save that, and you can use this same file. You can keep adding operations to this file and just add them to your knowledge base. You can use this to do all of your work on the knowledge base, or almost all of it.